There is a lot of buzz around AI agents these days, but building an AI agent is not as difficult as it looks. In this video, I'll show you how to build a research AI agent that reads Wikipedia, does a web search, and gives out a full report using Python, LangChain, and Groq LLM. So do watch this video till the end to understand how to build any AI agent from scratch step by step. This video is going to be beginner friendly, so even if you don't have any experience in building agents, you don't need to worry. Before diving in, please subscribe to the channel, and during the video wherever you feel like you learned something new, please like the video immediately. First of all, we need to have Python installed in our system. And it's better to have 3.10 or the later version, but you can try with other versions as well. Then we need to install some packages. So before doing that, let's create a folder for our project and create a requirements.txt file. In this file, we'll have to add some packages. So let me just copy paste these packages here. Now to install these packages, it is recommended to use a virtual environment. So we can create a new virtual environment using a venv module. So let's just do python 3-env agent underscore venv. So this actually uses the package venv and creates a virtual environment called agent venv. So you can see that it has created the agent underscore venv folder here, and this is the virtual environment for us. By the way, if you are on Windows, you can actually use Python instead of Python 3. Now we need to activate this environment. For this, we just need to do source and agent venv slash bin slash activate. If you do this, you can see that it has activated the virtual environment. And again, if you are on Windows, you can actually run something like agent underscore venv slash script slash activate, and this should activate your virtual environment. Now let's use pip to install the requirements. Pip install -r requirements.txt. Now it is installing all the packages. By the way, you can find this entire completed project in GitHub. So I am providing the link in the description. If you have any doubts, you can go through that. We can now set up the basic code required. So let's create a couple of files now. We'll create main.py. This is going to have our main agent logic. And then we'll be having the tools.py. And this is going to have the logic for the tools that we will be using. Now let's open the main.py and let's get into coding. Firstly, let's add a couple of imports. So from .env import load underscore .env, and from LangChain underscore Groq import chart Groq. So I'll explain about these import statements in a bit. We will use the .env module actually to fetch LLM API key from .env file. So we will have to create another file called .env, and in this file we will be storing our environment variables. We'll have to now load the .env file. For that we can do load.env and call this function. Now we can actually create our LLM using the chart Groq. But here this chart Groq actually takes a model which we need to provide. So for that, let's get into understanding how we can get our free API token from Groq, and also to understand what are the models that we have available. Now let's go to groq.com. You can find the link in the description as well. So why Groq instead of OpenAI or Claude API keys? Because Groq gives free API keys and provides access to basic AI models like Llama and DeepSeek. So you can use OpenAI and Claude API keys as well, but now you might have subscriptions for them. But for this project where we are just trying out some AI models, Groq is the best. Let's go to the developer section and open free API key. Here you can see that I already created a key, but let me go ahead and create another API key. Here you can provide a name for this. So I would say research agent API key, submit. And here you can see that it has provided an API key for us, and you can copy this and you can paste it somewhere. But if you close this tab, you will not be able to get this API token back. You might have to create another key. So it's better to just copy this right away and paste it somewhere. Okay, we have successfully created the API key now, but we'll also have to understand which model we'll have to use, right? So let's go to the Groq documentation and click on models here. And here you can see a table where it is mentioning all the models that are available. And there are different fields here, which you don't have to worry about right now. Here we can actually take one of these models. So for example, I am taking this Llama 3.3 versatile model. So just copy it. You can use any model from this list. If you are trying out any new model or different model than me, just let me know in the comments. Now let's open the .env file and type in Groq underscore API key. So this is where we will be storing our API key. So I am pasting my API key here. I'll not show it here because API key is very secret and private. You shouldn't be sharing your key with anyone else as well. So most importantly, do not push it to GitHub at all. Now head back to main.py file and update the chart grok call to add the model argument and paste the model name. Before that, let me just fix this import statement once. So in the chart grok, now we'll say model equal to, and we will be pasting our model name here. Cool. The API key that we just pasted in the environment file, so that will be automatically be taken by chart grok, so we don't need to set it up here. So let me invoke this LLM and see what happens. So let's do LLM dot invoke and let's ask something funny. Why do animals have tails? Not sure if anyone knows this, but I'm not sure. So let me just ask about it. So we'll be getting some response out of this LLM dot invoke. So let's just take this as response and print that response here. Now let's go to the terminal and run Python main.py. Here you can see that the AI has generated all the content for us. So it just says animals have tails for a variety of reasons, and the specific function of a tail can vary depending on the species, blah, 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 blah. So we got a lot of information here. So you can also see that it has given us information about the input tokens and the output tokens and the total tokens that it has consumed. So token basically means group of characters as one token. So in this particular case, it is saying that it has taken 41 input tokens and 513 output tokens, and the total tokens become 554 tokens. Most of the AI models do the costing around the number of tokens that are being used. So make sure that you are minimizing your total tokens that are being used. And you can do this using different kinds of patterns. Basically, you can decrease the amount of tokens that you're giving in the input prompt. Also, you can decrease the amount of tokens that you're getting in the output prompt by actually asking AI to limit the response to particular structure or something like that. Okay, looks like our setup is working. So we got a comprehensive answer about our tails, right? Now let's get into building an agent using this LLM. So let's import some more packages now. I'll explain each of them while writing the code anyways. So let's do from Pydantic import base model and from LangChain underscore code dot prompts. Let's import prompt template and from LangChain underscore core dot output parsers import Pydantic parser. Okay. Now let's create a model for getting our response from the user. So let's just create an object here. Let me just copy paste the model. So here you can see that I'm creating a model, research response. So it has topic, summary, source, and tools used. So we'll ask AI to actually provide the output only in this particular format instead of giving us like a blob of text. Agents can actually work without configuring a structured response as well. But by providing this, we are getting some certainty in the LLM output. So we can do some validations or extract required data easily. So it's always a good idea to use this structured outputs. Now let's create an output parser using Pydantic. Before that, let me just remove this response LLM invoke. So here I will do parser is equal to Pydantic output parser. And here in the Pydantic object, we can give our research response object. Now let's create the input prompt for the AI model. By the way, I use LLM and AI model interchangeably in this video, but don't get confused. They both mean the same. So that is a basic AI model only. So let me paste the prompt and explain it clearly then. So this is how I am creating the prompt. So I think we did something wrong in the import. So we'll have to import the chart prompt template, which we'll be using here. So we are creating a prompt here, chart prompt template dot from messages. This actually creates the prompt in a structured format. So in this, we are giving our first object as the system prompt. And here we're saying that you're a research assistant that helps users find information and summarize research topics. And we are asking after gathering the required information, provide a comprehensive summary with the format instructions. So this is the actual format that we have. So that is the research response object. And here you can see that the partial filling, we are doing like format instructions is equal to parser.get format instructions. So you can actually try printing printing the output of this parser.get format instructions. It actually gives a output like asking AI to give output in this particular format only. So it actually creates a string out of this object. Now, don't worry about the chart history and agent scratchpad. These actually get auto-populated when we actually run the LangChain agent. But you can research about it and understand how these two fields can like change your agent. So if you got some details around these fields, you can actually let me know in the comments. We can discuss further there. And user input is the input that the user will be providing. So that is something that we will be giving it to prompt later. Mentioning again, you can find the finished code in the GitHub repo, which you can find in the description. So check it out if you have any questions. Now let's move on to the most important part, that is creating an agent. For that, we'll have to add another input. Let's do from LangChain dot agents import create tool calling agent, comma agent executor. Now let's go down and let's create our agent. So we can say agent equal to create tool calling agent, and in the brackets you can open it and we can say LLM is equal to LLM that we are providing, and the prompt is prompt that is just created, and we will be providing empty list of tools for now. So once we create more tools, actually we can add them here, but as of now we will be creating this agent with no tools. And now let's use the agent executor, which creates an executable which can be invoked. You can do agent executor is equal to agent executor of, and we can provide the agent that we just created here. And let's provide the tools as empty for now. And we will say verbose equal to true. This actually provides some details about how agent is thinking. Now let's add a simple user input. So as of now, I'll just hardcode this input. Let's say we can ask about how elephants communicate. So how does elephants communicate? So let's see how agent responds. And let's say our response is equal to agent executor dot invoke. So if you're wondering how I'm getting all these autofillings in the code, that is because of GitHub Copilot that is integrated into VS Code. So do let me know in comments if you want to get more details about that. Now here you can say user input is user input. Let's print this raw response and let's go to the terminal again and execute this file. Python main.py. There we go. So we can see that here. So you can see that actually it is saying that it is entering the new agent executor chain. This is the line chain output that we are getting. And this is the actual output that we got from AI. And it says that is a comprehensive summary. And you can see that the output is structured in the format that we have specified, like topic, summary, source, and tools used. It has actually printed out all the response. But instead of like printing the output text, let's try to create a Python object out of the structured output that we are getting. So we'll have to parse our output. So let's create a structured response equal to parser dot parse response dot get output, and let's print this structured response. And let's also print the individual items that we have inside the structure response. Let me just copy paste all this. Now let's run this file again. Okay, cool. Here you can see that it has created, basically we just converted our string response into a proper structured response, which has all the fields that we need, like topic, summary, source, and tools used. And in the output, you can see that we have the topic, summary, source, tools used, everything basically. So far it looks good. But remember that we are dealing with LLMs here, and they can be a little unpredictable sometimes. So they might give us a response which is not in the requested format. So we need to handle such errors gracefully. To do that, we need to add a try catch block around the parsing logic. So let's do try here, and let's print all this inside the, let's do all this inside, and then the except exception is key. Let's just use this suggested option, error occurred while parsing response. We can just print this out. Cool. So far we created an LLM and tested it with some simple prompt. And we use the LangChain agent executor to invoke the LLM in an agent. And that's it. If we just want to create a simple AI agent, but we generally cannot call something an agent if it doesn't call some tools, right? So let's configure some tools in our AI agent and make it more powerful. Head to tools.py file now. So firstly, let's create a tool to query Wikipedia. This LangChain community.tools actually have a lot of tools. You can explore them and let me know in comments. So from LangChain community dot utilities, let's import the Wikipedia API wrapper. Now, one more thing we need is the from LangChain dot tools import tool. So using this tool, we actually will actually be creating the tool. Now, let's create the API wrapper now. So this is used to actually call the Wikipedia API. So let's write API wrapper is equal to Wikipedia API wrapper, and we need to pass a couple of parameters here. The first one is the top K results. The top K results basically means how many pages to actually return when we are querying. For this, actually, we can just have one. But if you want to get more pages out of Wikipedia, you can do that as well. And then let's use the doc content characters max as 1000. So this defines the number of characters that the Wikipedia API will be returning out of the document that it found. So in the document, the first 1000 characters will be returned by this API. Now let's create a tool using this API. So we need to first create the query run object. So let's do like Wikipedia equal to Wikipedia query run, and we'll be passing the API wrapper to this. Now we'll be creating the tool. So this is Wikipedia tool, let's call it. And it will be using the tool that we just imported. And here we'll be giving a name. Let's say search Wikipedia. And then the func will be wikipedia.run. So make sure that you're just passing the function here. Don't need to call it. So we can use the description that we are being suggested. So such as Wikipedia for the given query. So that should be good. Now let's go back to main.py file and import this tool. So here you can say from tools import Wikipedia tool. So from tools we are importing Wikipedia tool, and now in the agent we have tools where we can provide the Wikipedia tool, and also in the agent executor we'll have to provide the tool. So let's create an object separately with the Wikipedia tool here, and let's use that here. We are passing our tool to agent, and we are also passing that to the agent executor. That means, so when we are passing tool to the agent, what's happening is that we are telling AI model that these are the tools that we have available, and it needs to decide which tool that needs to be used based on the user prompt. And when we are giving it to agent executor, so that is actually executing the tool. So it takes the output from the AI, it takes the function name or the tool name and executes that tool. So to get better results from AI, actually we need to update our prompt as well with the information about the tools. So let's go to our basic prompt that we have and let's say tools that we have available here. So let me just paste the updated prompt. So we are just saying use the available tools to research the topic. So the first tool that we have is the search Wikipedia, and we are just mentioning for encyclopedic information. So that should be more than enough for AI to understand that this is to fetch the data from Wikipedia. Now let me test this file again. So you can go to terminal again and say Python main.py. And here you can see that it is invoking the search Wikipedia with elephant communication. And it got some data from it. So we have a page, elephant communication, and summary is coming. So you can actually verify this. You can go to Google Chrome, search for elephant communication Wikipedia, and you will actually be getting this page called elephant communication. And whatever data that is there at the start, so that is it. That is what is going to be the summary that we are getting here. Elephant communicate via touching, visual displays, localization, all this information is coming directly from the Wikipedia API. And you can see that it finished the chain and it actually created a summary out of the data that it got from the Wikipedia. But in the tools, we have mentioned that the max character that it needs to take is 1000. But here you can see that the data that we are getting is pretty less. So this is what we got. That's it. So what's happening is that the Wikipedia query run actually summarizes the data that it is getting from the Wikipedia. So even though it is getting 1000 lines of code, it actually does some algorithm inside and it actually summarizes that data. So in this case, it is just giving us the initial one line of the data that it is getting out. So to handle this, we'll have to actually update the tools to use the Wikipedia internal functions directly. So let me create a function here. So instead of this API wrapper that we are creating here, let's just create a function called search Wikipedia full content. And we'll be getting a query here. To make this quicker, let me just copy paste all the content that we have here. Okay, cool. Yeah, in this function that we just created, what we are doing is we are creating the API wrapper and we are fetching the document using the API wrapper.load. So we are not using the Wikipedia query run anymore. And from the documents, we are fetching the first doc that we are getting. In the page content, actually, we are getting the full content. And we are just returning the title, URL, and the full content here. Now, in the Wikipedia tool, instead of this Wikipedia.run function, let's use this search Wikipedia full content. So in the description also, let's say search as Wikipedia for the given query and returns the full content. Now let's go to main.py file again and run this file. So now you can see that we got a lot more data compared to the one line that we got earlier. So it says the title, URL, and the full content. It says this particular line that we got earlier as well. But in addition to that, we are getting all the other paragraphs as well as we are fetching the complete data. So this actually gives AI more data to actually summarize the output. So we can see that all this data is being fed to AI and AI is actually creating a summary of all this data and creating a small research output for us. Now, similarly, we can add a web search tool as well. So for this, we can use a LangChain tool called DuckDuckGo. So let's go ahead and import the DuckDuckGo tool here. DuckDuckGo search run and let's create a tool. So before creating the tool, we'll have to create a search object, which is the DuckDuckGo search run. And then we'll be creating the search tool, which will be the tool, and the name will be search web, for example. And the func again, search.run. Do not call the function, just pass the function. And the description, we can use the one that is being suggested here, searches the web for the given query and returns the results. So that's it. We just created another tool. Now go back to main.py. Let's import the tool here, new tool that we just created, search tool. And now come to the tools section and let's use the search tool here. And also let's go to the prompt that we created earlier, and let's add the search web as the another tool option that we have. So in addition to what is being suggested, let's also add like so it says for general web search, use this tool whenever we need some latest information or news articles. So this actually helps AI to understand when to use this tool. So now let's just run this file again. So we are getting an error that we are missing a package called DDGS. I think it is part of the DuckDuckGo search. So let's just add that DDGS package into requirements and let's install these packages again. Now go back to main.py and let's execute this file again. Okay, here you can see that it is invoking the search Wikipedia with elephant communication. It got the Wikipedia output. Now it is also invoking the search web. We can see that both our tools are working fine, and it actually uses both this information and creates a summary. Now instead of hard coding our user input, let's actually take this from the user directly in the terminal. So let's do input, provide your research topic. So let's run this file again. So it says provide your research topic. This time let's try to search something which is in the trending right now. So research about the trade war between US and China. It's triggering the search Wikipedia tool and it's fetching some data, and it is doing the search web with US China trade war latest news, and it has created a summary of it. So the US China trade war is an ongoing economic conflict between the United States and China that began in 2018. Blah 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 blah. So that's it. We have created a basic AI agent using LangChain. So this is pretty simple, right? So you can see that we are just using some functions that LangChain is providing, like create tool calling agent and the agent executor. And we are just providing LLM that we just created from Groq, and then the prompt that we created, and the tools that we have created using Wikipedia and the search web, DuckDuckGo search that we imported from LangChain. So everything here is ready-made. So all the things that are happening, like LLM and the tools, everything is actually ready-made and available in LangChain. So you're just using them and creating an agent around it. So this is how easy it is to actually create your first AI agent or any AI agent basically. Obviously, this we are just scratching the surface here, but these are the basics about the AI agent. So even if you are creating like a big multi-agent system, these are the basics that you need to know. Thank you so much if you are still around. Please like, share, and subscribe to the channel for more amazing AI content.